Question 64, a very, very beautiful problem that comprises both conservation of momentum and circular motion. We have two objects, the bullet and the mass that is on the string, collide. As a result of the collision, what they're telling us is the bullet emerges with a speed. So the bullet passes completely through the pendulum. That means that this collision is not elastic, but it's also not perfectly inelastic because the bullet doesn't embed itself in the big mass. So it goes through, has this velocity, and then as a result of that collision, the mass on the string, the pendulum, is going to also have a velocity, and that velocity will allow it to complete this circle, and it says barely through a complete vertical circle. Remember, barely is when we have velocity so slow that mg, which is the force, is equal to centripetal force, mv squared over, and my distance, my radius in this case, is that little l. Masses cancel, so my v final for the big M in this case is going to be equal to gl, if that is the velocity of my big M at the top. What was it at the bottom? At the bottom, now we're talking about conservation of energy. So for the big mass M, conservation of energy tells us that at the bottom, kinetic energy at the bottom should be equal kinetic energy at top plus mg2l, because that is the double radius. This height right here at the top is 2L. What is K at the bottom? It's the big M times V at the bottom squared over 2 should be equal to big M V at the top squared over 2 plus big M G 2L. All right, that's the conservation of mechanical energy for the pendulum. Masses cancel. I'm just going to multiply everything by 2 to get rid of it. Velocity at the bottom squared should be velocity at the top squared plus 4gl. Now, what was velocity at the top squared? I forgot the square right here. I apologize. So velocity at the top squared is gl. Velocity of the bottom squared is going to be 5gl then. So then velocity at the bottom is going to be a root of 5gl. From there, I'm rolling back to conservation of momentum for this collision. So conservation of momentum for this collision tells me what? It tells me that the mass of the bullet times initial velocity of the bullet, which is what I'm after, equals little mass. And it says that after the collision, it has the half of that. So I'm going to use that plus big M. And then my velocity at the bottom is root of 5gl. From there, when I rearrange this is mv initial over 2 should be equal to big M root of 5gl, from where v initial, which is what I'm after, it's going to be 2 masses root of 5gl divided by the little mass. So this is your minimum initial speed of the bullet right before this collision.